Hey guys, welcome to MoeTechie, and today I will be going over a basic overview of what an IP address is and its role on a network. Think of an IP address as a numerical name you give to a device such as your computer, printer, or mobile phone so that it can identify itself on a network. So instead of giving it human readable names such as Tom, Bob, and Larry, you give it an address like the one you see on the screen. This is so that they can find one another and exchange resources and communicate. Another way to think of it is think of your home address. It uniquely identifies where you live. And if you wanted to communicate with a friend in another home, you can send a letter where you would place their home address as the destination. You use this concept of a home address to be able to identify and send information, and a way for you to communicate with a peer. Just like that, IP addresses are like home addresses, but for your computer or network devices. So let's dive into a little bit more on the IP address we have on the screen. This is just an example IP address. It's a very common IP address, and you might even have this IP address on your network. So this IP address, simply, it's four sets of numbers, and they're separated by a decimal. Each of these numbers over here, they can range, and I'm actually going to write it down. Each of these numbers over here can range from 0 to 255. Same thing for, this. So you'll commonly see this IP address called a 32-bit address. And that's because each of these numbers can be represented by 8 bits. And that's why each of these numbers are also called octets, because it takes 8 bits to represent this number over here. So there's one other thing that you need to know, and that is the subnet mask. The subnet mask is very similar to the IP address, that it has four numbers separated by a decimal, and these are four common subnet masks that I have on the screen. So you can see them commonly get written like this: 255.255.255.255, or they'll be represented in something called a CIDR notation, which is over here. Same thing for this one over here, 255.255.255.0, the /24. So these numbers are the amount of bits that are turned on. So whenever you see a 255, that means there's 8 bits turned on. 8 times 4, 32. Same thing for this. You have 8, 8, 8, 24. So the purpose of a subnet mask is to determine which part of your IP address belongs to the network and which portion belongs to the host. And the reason you want to know that is because for devices to be able to communicate with each other, they have to be on the same network. That means the network portion of their IP address must be the same. So let's go through a quick example. Suppose you have one computer that's 192.168.1.10/24 and another computer that's 192.168.1.20/24. So /24 means that it's 255.255.255.0. So what you'll do is whenever you see a 255, that means that portion of the IP address would be part of the network. So I would just put this underneath here, 255.255.255.0. So wherever I say 255, that's network. Same thing over here, 168.1. So these three are part of the network address. And then wherever you see a 0, that means that this portion is part of the host. So this 10 right here, this is the host portion. What that means is that any device on your network that starts off with the same network address, this network portion, will be able to communicate with this computer. And the host just means that this number can range between 0 to 255. So in this case, this device that has this IP address and this subnet mask will be able to communicate with this computer because it has the same first three portions of the network address. So I'm also going to show you guys how to find your IP address on your Windows or Mac computer. There's also another IP address that I'm going to show you, and that's called a default gateway. And that's the IP address that's assigned to your router. So whenever you want to go out to the internet, your computer is going to point to the default gateway so it can go out to the internet and go fetch whatever you're looking for. For example, if you're trying to go on youtube.com, you're going to leave the router out to look for youtube.com out in the internet. So this is how you'll find the IP address on your Windows computer. And as you can see, there's going to be the IP address, the subnet mask, and the default gateway. This is how you see the IP information on a Mac computer. All right, so let's do one more example, and let's do a visual one so we can get a better understanding of everything we learned so far. So we have a network over here. You have your router. Suppose this is your home network. You have a printer, you have a laptop, a desktop, and your mobile phone. Both your mobile phone and your laptop are connected wirelessly via Wi-Fi to your router, and your desktop and printer are connected directly via a wire. So all of these devices also have an IP address. And we're going to say that each of these devices have a subnet mask of 255.255.255.0, which is also a /24. So in this example, we can tell that because it's a /24, the first three numbers over here are going to be part of the network. Same thing for here, same thing for here, and same thing for here. And one thing we can tell is that because these first three numbers are all the same, all three of these, well, four of these devices will be able to communicate with one another. So for example, if this desktop wanted to print a document on this printer, it would be able to go over and send that print job to the printer because it knows where it lives and it lives on the same network. Same thing with your cell phone and your laptop and your desktop and your cell phone. They would all be able to communicate because they live on the same network. So you may be also wondering, how do your devices get these IP addresses in the first place? Well, that's actually a service that's handled by your router. So the service is called Dynamic Host Configuration Protocol. And the purpose of that is to just hand out IP addresses. So all devices that want to participate in the network will all get an IP address assigned to them by the router. So the last thing that I wanted to go over is something with the router over here. You'll notice that it has two IP addresses. One is on the inside and one is on the outside. And there's a reason for that. So originally when IP addresses were created, engineers did not ever think that IP addresses would run out. With the explosion of the internet and the vast number of devices that require IP addresses, we soon realized that we had a shortage of IP addresses. And there is actually a theoretical limit of how many IP addresses there are. There are actually 4,294,967,296 possible IP addresses that we can uniquely give to every device. With the vast number of devices out there, we can't give every single device an IP address. So one of the things that were created to kind of prevent the depletion of IP addresses, public IP addresses, were the creation of private IP addresses. So everything you see here behind this router, all these IP addresses are actually part of a private IP address range. And this IP address that you see over here is actually a public IP address. So the idea is that you have private IP addresses which are not unique to the world, but you have public IP addresses which are unique to the world and to the outside internet. So the idea being is that every device behind your router will be utilizing a private IP address, and whenever you go out to the internet, you'll actually be using a public IP address. And there's also a service that handles that. And that service is built into the router. And that's something called network address translation. And what that proposed is, hey, whenever one of these devices want to go out to the internet, your router is going to translate that private IP address to a public one. That way you conserve IP addresses. So devices out on the internet, suppose you wanted to go to youtube.com. So your computer will say, hey, I don't know where youtube.com is. Let me send this information to my router, specifically the default gateway, which is this inside IP address of the router. And then your router's job is to route and find how to get to youtube.com. So before it tries to send that information, it's going to translate your private IP address to this public one and then send that data out to the internet to find youtube.com. And the YouTube servers out somewhere on the internet, when they see your request coming in, they won't be seeing that private IP address. What they'll see is that public IP address as the source. So if you guys are interested, I also placed the private, public, and special address range for the IP addresses. And one thing you'll notice is these are all IPv4. So throughout the video, we were talking about IPv4 addresses. There's also an IPv6, or version 6, which was created to kind of help with the whole depletion of IPv4 address. IPv6 has a lot greater range of IP possibilities. Every device on the world can have an IP address if you're using IPv6, but the world is mostly still using IPv4. So I hope you guys like this kind of video. Definitely like, comment, subscribe. This video came out to be a lot longer than I expected, but definitely stay tuned. I'll have more content coming out, and I hope you guys got MoeTechie. Take care.